When you use a tool like GPT, it can feel like actual magic. You type in a question, and bam, this surprisingly human-like answer just appears. But it's not magic. It's a process. And today, we're going to pull back that curtain and show you exactly how these incredible tools really work, step by step.
Really, it all comes down to one big question. How on earth do you teach a machine, a pile of circuits and code, the very human, very messy art of language? That's the core puzzle we're going to solve together in this explainer. So here's our game plan. We'll start with the basics, what an LLM even is. Then we'll try to wrap our heads around the unbelievable scale of these things. After that, we'll break down the core formula behind them, look at how they're actually trained, and finally, see how they're making an impact out in the real world. Okay, let's dive right in at the beginning. Before we can understand how they work, we need to get on the same page about what they actually are.
A large language model, or LLM, is built on top of something called a foundation model. The best way to think of a foundation model is like a massive general-purpose brain. It's been fed this enormous buffet of text from the internet with no labels or instructions, and it just learns to find patterns all by itself. An LLM is a version of that brain that's become a specialist at one thing, generating language that sounds like us.
Now, let's really focus on that first word, large. Because the scale we're talking about is, well, it's pretty much impossible to fully comprehend, but it's absolutely fundamental to how these models work so well.
To even begin to grasp that scale, we need to understand this word, parameter. Think of a parameter as a tiny adjustable knob inside the model's brain. As it learns, it's constantly tweaking billions of these little knobs to get closer and closer to the right answer. The more knobs it has, the more complex and nuanced its understanding can become.
So how many of these little learning knobs does a model like GPT-3 have? Get ready for it. 175 billion. That's 175 billion individual values the model is adjusting every single time it learns. That gives you a sense of the just staggering complexity we're dealing with here.
And what are all those parameters learning from? An absolute ocean of data. GPT-3 was trained on 45 terabytes of text from all over the internet. Now, that's a number so huge that, on its own, it's pretty much meaningless. So let's try to put it into context.
This really helps. Think about it. 1 gigabyte of text can hold about 178 million words. That's a lot, right? Well, a petabyte is about 1 million gigabytes. We are talking about an astronomical amount of reading material. Books, articles, conversations, a huge slice of the public internet, all fed into one single learning model. It's just wild.
So, with all that mind-bending complexity, you'd think the basic concept is impossible to understand. But what's so surprising is that the entire recipe for an LLM can be boiled down to just 3 main ingredients.
And here they are. First, you need that massive mountain of data we just talked about. Second, you need a special kind of digital brain, an architecture, to process it. And third, you need a training process to make it all learn. Data, architecture, and training. That's really it. That's the whole shebang.
So that second ingredient, the architecture. For today's LLMs, that means the transformer. You could say its superpower is understanding context. For instance, in the sentence "the bank of the river," it knows bank means the land next to the water, not a financial building. How? It's smart enough to see the relationship between bank and river, no matter how far apart they are. This is what unlocks its deep grasp of meaning and nuance.
Okay, so we've got the data, we've got the architecture. Now for what is, I think, the most fascinating part. How do you actually teach this machine to write?
This is going to sound almost too simple to be true, but this really is the core of the entire process. The model gets part of a sentence, and its only job, its entire purpose in life, is to guess what the very next word should be.
At the beginning, its guesses are completely random. Hilariously bad, actually. It might see, "the sky is," and guess bug. The training data then says, "Nope, sorry, the correct answer is blue." The model recognizes it made a mistake and then makes a tiny adjustment to some of its 175 billion knobs, making it just a little more likely to guess blue the next time.
And that's the core loop. The model makes a guess, it gets corrected, and it adjusts itself. Now just repeat that simple process billions and billions of times across all 45 terabytes of data. Over time, its predictions slowly transform from random noise into coherent, structured, and uncannily human-like sentences. So this first big training process creates a powerful model that knows a little about everything, a jack of all trades. But you can take it a step further through what's called fine-tuning. By training it again on a much smaller, specific set of data, like only legal documents or only medical research, you can turn that generalist into a true master of one specific task.
So we've gone through the theory, the scale, and the training. But let's bring it back down to earth. Why does any of this actually matter? Well, let's look at the real-world applications that are already changing the way we all work.
I mean, businesses are using LLMs all over the place. They power those intelligent chatbots for customer service. They're used for content creation, drafting everything from emails to marketing copy. And they're even transforming how software gets made by helping engineers write and check their code. And these are just a few examples of their growing impact.
And yep, they can even help write scripts for online explainers, which is a pretty meta thought, isn't it? But it just goes to show you how incredibly versatile this technology is becoming. So, we've demystified the process. It's not magic, it's the result of massive data, a clever architecture, and just relentless training. We now understand how these models write. The real question this leaves us with is, what will a technology this powerful imagine next?